Okay, this WebEx call is being recorded and may be posted on DOE's website or used internally. If you do not wish to have your voice recorded, please do not speak during the call. If you do not wish to have your image recorded, please turn off your camera or participate by phone. If you speak during the call or use a video connection, you are presumed to consent to the recording and use of your voice or image. So it gives me great pleasure to welcome you all to the U.S. side event to the IAEA 65th General Conference. Our session is entitled U.S. Deployment of Advanced Reactors, and we're going to be focusing on financing and project development issues with a focus to achieving net zero goals. We have three panelists with me today. I'll be your moderator, Paul Murphy. I'm the founder and managing director of Murphy Energy and Infrastructure Consulting. Our other panelists are Amjad Ghouri, Ed Key, and Dan Littman, and I'll just take a minute to introduce all of them before we get into the discussion, which will kind of be sort of a fireside chat format. So Amjad Ghouri is the managing director of Aegeus Advisory Limited, a London-based boutique strategic and financial advisory firm he established in 2018. He has over 25 years of experience as a developer, investing equity and raising financing for independent power and water projects, and a banker specializing in project finance advisory to clients in the global power and infrastructure sectors with a specific focus in emerging economies. During this time, he has led financial advisory teams providing advisory services to public and private sector clients, developing LNPPs in Central and Eastern Europe. Since January 2018, he's been working in a number of areas in the nuclear space that are quite interesting for our discussion today, to include serving on the Expert Finance Working Group under the UK's Business Energy Industrial Strategy Group, created to evaluate pathways to attract private sector financing and the roles that the UK government needed to play in order to mobilize private sector financing to fund the development and deployment of SMRs. He's recognized as an expert in the development and financing of nuclear power projects and national programs by the IAEA, USTDA, and IFNEC. He also teaches financing and project development for the IAEA Argonne National Lab and is an affiliate of Nuclear Economics Consulting Group. So Amjad, welcome, and thank you for joining us today.
My pleasure.
Our next guest is Edward Key. He's the CEO and founder and principal consultant of Nuclear Economics Consulting Group. He's an expert on nuclear power economics, providing strategic and economic advice to companies and governments on nuclear power and electricity industry issues. He's testified as an expert witness in the United States and in international legal and arbitration cases. Prior to founding NECG, he's served in a variety of roles, including at NERA Economic Consulting, CRA International, PA Consulting Group, McKinsey & Company, and also as an independent consultant. Prior to all of this, he was a merchant power plant developer and a nuclear power plant engineer, qualified as a chief engineering officer on Nimitz-class nuclear aircraft carriers before becoming a consultant. He's written a number of articles on these topics and has written and published a book entitled Market Failure, Market-Based Electricity is Killing Nuclear Power, which was released earlier this year. He teaches for the IAEA and other audiences. And again, Ed, thank you for joining us today. And last but certainly not least is Dan Littman. Dan is a career nuclear industry professional with the last 23 years as an executive heading the nuclear reactor business for Westinghouse Electric Company and serving as vice president, suppliers and international division at the Nuclear Energy Institute. He's recently undertaken assignments as a strategic advisor, board member, and operating partner and executive in support of new reactor and fuel cycle projects, working both domestically and internationally, including with both emerging and existing nuclear technology developers. Dan has most recently focused on support for commercialization of new reactors, SMR technology development, and trade promotion and nuclear policy support for U.S. government agencies. He began his career working in interesting places like Korea and in the United States, developing nuclear reactors and reactor programs. And the bulk of his experience is in international civil nuclear trade and cooperation, reactor sales, new technology development, R&D, tech transfer, and organizational development related to companies. that are active in this space. He has particular interest in emerging nuclear markets, having led trade missions to several countries, performing due diligence on nuclear companies, and participated in many multilateral negotiations and government-related meetings, and serving 4 times on the advisory committee to the U.S. Secretary of Commerce on nuclear exports. So with that, again, thank you, Dan, and we'll get started. So our format today is really to just have a conversation among the 4 of us about issues relating to the nuclear industry. There's a core emphasis on financing, of course, but as you'll see, hopefully in our discussion, the connection with a lot of related issues to include project development, structuring, and other issues. And so, maybe to get us started, it seems like there's a bit of a buzz in the nuclear industry these days that maybe wasn't there before. And so maybe I'll start with you, Dan. What do you think is getting people excited? We had the nuclear renaissance that was supposed to happen in the early 2000s, but it feels a little bit different this time around. What do you think's driving that?
Thank you, Paul, and thanks also to our colleagues at the Department of Energy for sponsoring this discussion. Look, I think it's fair to say we didn't suddenly have interest in new nuclear overnight. I'd say in the last 6 or 7 years, there's been a steady increase in interest, not only in the United States, but especially in the United States and outside the United States on deployment of nuclear. What's really changed, I think, in the last several years has been the emphasis on climate change, which we're going to talk about later, I would suppose, but also the emergence, finally, of small modular reactor and advanced reactor technologies. That's really been, I think, a more recent development as they become closer to becoming a commercial reality. Because with them, with small reactors, you get the ability to deploy nuclear technology with lower overnight capital costs than nominal dollars, that's for sure. But you also get different products. You get more local, in other words, closer to load center electricity generation. That's number one. And number two, you have different products now. You have the potential for hydrogen and other non-electricity applications for the technology. So I think when you put all those together, climate, the interest in the development of new technologies and what those new technologies bring to the party, you have a situation now where there's quite a bit of interest in the deployment of new nuclear technology.
I mean, Ed, we've seen in the U.S. that the existing fleet has had some challenges, and at the same time, there's been maneuvers to put in place supports to keep the fleet running. I mean, what does that tell us about current market conditions, and as we look to develop new reactors, what are some of the influences that we see from that market side that may influence our thinking a bit?
Well, look, and my book is mostly about this, but the issue is that these marginal cost-based market, single market price model markets end up having prices that are, they're easy to predict for an hour or a day or a week, but to project those prices out for decades is very difficult. And in some markets, like the US market, we're blessed with really huge quantities of cheap natural gas that drives those prices down. And we also have a lot of renewables coming in that also drive those prices down. So in the US market, in the organized markets, nuclear power is having a hard time. And we've done some things, some states have done things to provide extra revenue based on the public goods provided, primarily those public goods that are being compensated in New York and New Jersey and Illinois and other places are clean air. And that's been a big move. There also is, in the new Infrastructure Act that's coming, a civilian nuclear credit that does sort of the same thing if that's implemented, and a clean electricity payment program that'll maybe also help these existing nuclear power plants by providing money for attributes that provide public goods that may not be compensated in short-term electricity markets. And those lessons from the US markets are flowing into Europe. Similar issues arise in Germany, similar issues arise in any market. And I think the solutions are increasingly looking like some outside party, outside the market party, providing fixed revenue that makes the nuclear power plant viable. And may that lead to regulated or government-owned projects? It might.
So Amjad, you sit in London, US citizen, UK citizen, you have sort of a unique perspective working with the US government, but also having supported the UK government on a number of things. So you sort of may see things from a slightly different perspective. Clearly, nuclear is a priority for the Biden administration under this climate change theme and clean growth, clean energy. How do you see things from the UK in terms of both what the UK has been done, intends to do, and also Europe a little more broadly? What kind of trends are you seeing that gets into this? Hey, maybe things are a little bit different this time around.
Thanks, Paul. Thanks for having me on this, and thanks to DOE and Alicia for allowing me to speak and express my opinions sitting where I sit. I think what I've noticed is nuclear growingly being included in the context of clean energy and achieving sort of the greenhouse gas emissions that a lot of countries in Europe are very keen to do, and most importantly, achieving net zero. So it's that momentum, you talk about ESG, there's a lot of discussion about nuclear getting the space. So there's a general shift in thinking in UK. UK is already, I think, ahead of the game, but certainly in Europe. And what we've seen the UK do, UK has um, a potential problem because they've got old nuclear units coming off. They're large-scale projects, nuclear projects that they had embarked on doing. Not all of them are going to be done. And the ones that have been approved are going to take a little bit longer. So people are looking ahead and saying, hey, in 2025, we're going to have our 2025, certainly by 2030, we're going to have a big gap. And where is it how is that gap going to be filled? And I see increasingly people saying, well, let's support SMRs and let's make that the vehicle to achieve our clean energy goals.
So you've hit on ESG and on SMRs, and we certainly want to address that, but maybe just taking a step back first, when we think about sort of where the ultimate test is for nuclear projects, it's, are they financeable? And nuclear projects have had a challenge in putting together financing. So, starting there with what we know about the challenges of nuclear, why is financing so important, and why is it one of those greatest challenges? What are the things that make nuclear power projects different, and some of the unique factors that we have to consider for a nuclear project as opposed to maybe other types of project? Maybe Amjad, if you'd kick us off.
Sure, Paul. I mean, nuclear is unique, and there's certain risks in nuclear that you normally don't have in conventional power projects. And financing in terms of risk assessment, risk allocation, financiers look to see who can bear those risks, who is best suited to bear those risks. And in nuclear, unfortunately, financiers are very reluctant to bear probably one of the most important risks, absent design, absent the technology risk, but construction. So in that sense, construction risk is massive, and the large upfront capital outlays, combine that with the construction risk being so critical. It's hard to get financing and get financiers to come and take that risk during the construction period. So you actually need to have a big role played by the government, and you're seeing that happen certainly in the SMR space. You've got DOE supporting multiple projects, SMR technologies in the US, NuScale, Natrium, X Energy. And on the UK side, you've seen UK government commit funding to get the Rolls-Royce SMR off the ground, at least get a couple of units done until you get to nth of a kind. Now, when I talk about these risks, this is all first of a kind, and that's what's most important. I think perhaps like in the conventional sector, once you've got reference plans, you've got equivalent operating hours, you have a picture that, hey, once these things can be built safely, they can be built, on time, on budget. You're going to need less of that massive role that the government plays, at least on the front end.
Can I pile into that, Paul?
Yeah, absolutely. Because I was going to
I'm
ask
just-
you before you even do is in your answer, just sort of, how might moving to SMR start to change that dynamic a bit? So fire away.
Yeah, and I'm not sure it changes it dramatically in a certain sense. I mean, Amjad talked about the construction risk. When Amjad talked about first of a kind risk, there are several risks therein. So one of which is licensing risk. A lot of this is new technology. Is it going to be licensable? And I'm thinking in the shoes of a buyer, if I were an executive in an emerging nuclear country, what would I be looking for? So I'd be looking for assurance that what I'm going to buy is licensable, that it's a mainstream type of technology, and it's clear that the DOE programs to deploy demonstration projects is really, to answer your question, Paul, really very, very important, to mitigate that risk. That's very critical. Why? Because those demonstration projects will dispatch with licensing risk, right? In other words, they have to be licensable. Second, the other first of a kind risk is what you would call technology risk. What do I mean by that? If I'm going to turn the key, is it going to work? Am I going to have a nuclear reaction that turns a turbine and makes electricity? It will mitigate that risk as well. So I think that those risks are important for any buyer, and those demonstration projects, be they in any country in the world, are very important in mitigating those risks. And SMRs, the economics of SMRs are still being worked on because the designs are progressing, and we'll learn more and more. But the overnight capital costs in nominal dollars, one expects to be a lot less, and therefore potentially, to get back to the subject here, more financeable in that the overall amount is less. Thank you.
I mean, Ed, when all of us have taught for IAEA or at Argonne, one of the courses that you've given is on, why projects go bad and, lessons learned from all of that. But I mean, just for the perspective of our audience, there tends to be this view that nuclear projects run over budget and over schedule, which, that's something that the industry has to deal with. But to put it in the proper context, I mean, don't we see these types of problems in sort of the mega project classification, multi-billion-dollar infrastructure projects? Do we see that some of these problems are not unique to the nuclear industry, so that for people planning programs that, complicated projects tend to have issues that need to be dealt with? How would you assess nuclear relative to the energy and infrastructure space?
Sure. And I guess that course, I don't mean to be Dr. Doom here, but there are a lot of ways you can think about nuclear projects and how they don't work out. And I think there's a pretty well-developed body of knowledge out there that large projects, large meaning several $billion, several years to build, whether it's a pipeline or a drilling platform or anything, are going to have problems. And the problems come about because of several things. And nuclear power is maybe the worst of some of these things. It's something called optimism bias. We want these things to work. We believe they'll work. internally, both at the buyer, the seller, all the people in the project think they're going to work. And so we tend to discount or ignore, or maybe not think deeply enough about how things might be different than the best base case. And that's one point that's clear across all of these mega projects. And there have been a lot of articles and studies done about that. The thing that makes nuclear maybe different in a way is that we have, as Dan said, this nuclear safety licensing issue, which maybe isn't really replicated in any other industry so well. That's a hard stop if there's a problem. It has a lot of requirements that maybe aren't so clear. Look at the problems of some of these projects. They come about because a builder didn't follow the rebar drawings. The builder didn't buy a diesel generator that's been certified for reactor safety use, that kind of thing. And that causes problems. The last point, and maybe going back to the beginning of your question, what does failure mean for these projects? I guess it's not so much a failure if a project is over budget and delayed if it gets built and operates for 60 years and does really good things. Failure would be something at the other end of that, which is you build a plant and then it's abandoned and written off. The Seabrook project in the US is a great example of that. For whatever reason, that project didn't ever make it to the point of operating, even though it was finished. Huge write-off, huge problems. So abandonment's clearly a failure. Over budget, over schedule is a problem, but that's solvable. And if these other benefits and the long life of a nuclear power plant are there, those are not deadly. And the last thing I'll say is about this long life. We have a problem in evaluating nuclear projects because they're going to operate for 60 years or longer. And there's nothing out there in our financial toolkit that says how we value cash flows after about 30 years. They're not worth anything with any kind of reasonable commercial discount rate. So there's got to be a new way to look at these projects and say that last 30 years is valuable. How do we push that back into today's world and have some value for that may offset things like cost overruns or higher than we expect cost estimates? Because these plants are valuable. They're valuable for a long time. And we need to reflect that in the way we do financing, if not development.
So
Hey, Paul, yeah, I want to
let me-
close. Can I just close
I
this
was going to come to
discussion?
you anyway. So go ahead, and then I'll ask a question. So go ahead.
No, I think one of the things you started out in saying, about financing, why is financing so difficult for nuclear? Well, we've all talked about the risk associated with that. And you have to realize that in the non-conventional, non-nuclear project space, there's a whole host of financing available because they understand the risks. And as we know, project financing is available. They assess the risks properly, they allocate the risks, and because of reference plans, all that we've just said, there's a lot of money available in multiple tranches. You've got bank debt, you've got now institutional debt, capital markets is also available. That's not available for nuclear, especially relating to project finance, which I know a little bit about. It's because nuclear doesn't give rise to the kinds of things that are very important in project finance. That's operating control, taking security in an asset. Those just don't give, people, banks don't want to do that. Financiers just don't want to do that. And that's why project financing is not available, at least at this stage, for nuclear projects.
And probably for the host country, when it's a strategic asset in your country, you might not want a bunch of bankers taking over a project.
Exactly.
Yeah. So Ed hit on sort of our financial models maybe fail us a bit because of the long asset life. So I wanted to come to you, Amjad, on, let's put some other things into the mix, like energy security, energy diversity, clean energy, the value of clean energy. None of these things are a number you plug into a financial model either. So, in your opening comments, you mentioned the role of government, and so some of these larger beyond project issues for a project level developer may not matter in a financial model sense, but if these are benefits to the nation, to the economy, how should governments be thinking about this in terms of, looking at what you did in the exercise in the UK, and some of the things about what the UK is taking from maybe the way they thought about Hinkley Point and the contract for difference versus maybe even adjusting to do more things that the government might need to bear some more risks. Is sort of the benefit of that in part to capture, energy security, energy diversity, clean energy that maybe don't model? And from a policy perspective, how do you sort of get governments to step up and do this to quantify these benefits that don't plug into a financial model?
Hmm. That's a very good question and a tough one to answer. And the only comparison that I can make is that now there's a lot of discussion when you're talking about comparing cost of LCOEs. Now there's a lot of discussion about incorporating systems costs, and then coming up with what's going to be the overall cost of a particular technology. And I think people have managed to quantify those system costs, like building of new transmission lines and the space that is going to take to build out massive amounts of wind projects or solar projects, and all those have a systems cost, and it's going to require people kind of putting their heads together and saying, and it's going to have to be political and an economic decision, because the economics may not always bear themselves out, but you can at least come up with an economic number that you can plug into the model, and then it becomes a political decision whether, hey, is this really worth it for my country? Does this preserve my security of supply? Is this going to help me reach my, GHG emissions targets? Am I going to get to net zero? And so it's a balancing. I believe it's a balancing between the economics and ultimately a political decision.
So I want to hit Ed and Dan real quick on two things. I mean, first, Ed, on, you know, we built every nuclear reactor in the United States in a regulated market at the time it was built. And now, obviously, that's changed and markets have changed everywhere. And when we start talking about these intangible benefits, and Amjad mentioned total system costs, and the Nuclear Energy Institute's done some really good work, or Nuclear Energy Association, excuse me, has done some really good work on that if people want to read it. Have the markets failed us a bit in terms of, how we're developing electricity projects and generation projects, and nuclear's role in it? And if so, what do we do about it from a planning perspective?
Yeah, look, your point about the regulated companies building all of the US fleet, except for the ones that were pseudo government like TVA, similar issues. Those companies reflected the state regulator view of the world. The state regulator says we want reliable power, we want clean power, we want jobs, much like a government in some other countries would do. And they reflect those views and those attribute desires, if you will, into their generation mix. And in doing that, allow the utility to make investments that are recovered in their rates. And that worked. And that's happening in Vodal right now in Georgia. Other states may do the same. The nearest to real project SMRs or advanced reactors we have are at the UAMPS project in Idaho, the owners of which will be public power companies who have a similar mandate. They have members, they need to meet their members' demand, they can reflect these attributes and recover them in rates in a way that a market company couldn't. And I guess the markets, as we talked a couple of times here, don't reflect things like, in the US at least, clean air, system reliability, long-term operation, inertia, a whole range of things aren't priced into the short-term electricity markets, and that causes problems. So we have to figure out a way to fix that. An increased role of government is a way to do that. These side payments are another way to do that. There are a whole host of things that could be done. Other countries may not have as many states as we do, but they have similar issues if they have a market.
So Dan, I wanted to come to you, and I know you're dying to say something, but let me just ask the question and then please jump in with whatever else. But I wanted to ask you, we're talking about sort of the role of government and, intangible benefits or public policy justifications. I mean, you've been in countries working at the earliest stages of some programs, and, you know, as you've seen it in sort of the lessons learned, what's worked well, what hasn't, in terms of, the early justification of why do we want to do this? How do we make this happen? Why should we expend government resources? Why should the government maybe take some risks that private companies may not be able to take? You've kind of seen that in real time in a number of places. So, you know, what do we take from all that? And so please incorporate that into your answer, because I know you wanted to comment on some other things as well.
Yeah, I wanted to build, I think, and part of the answer to your question, I think, building on what Amjad and Ed talked about. Listen, at the very beginning, when you asked this question, you mentioned what I think economists call externalities,
Yeah.
things that are outside the purview of the economics of the project, greenhouse gas emissions, economic development. Let me add a couple. Technology transfer, something American companies are especially good at, and having in the host country an ability to bootstrap local industry with the ability not just to construct, but to fabricate sophisticated components. And where there is a country that is already a mechanical and electrical fabricator, to move up that quality chain to do nuclear level components. Tremendously important. And then the last one I'd say is energy independence. There are countries in the world that use energy exports as a way to maintain control over their bilateral relationship. And so one of the drivers I have seen in a number of countries is the desire for energy independence, and how nuclear contributes to energy independence nationally. So those are sort of the external factors. Now the trick here is, and it gets to Ed's point on the role of government and your question, how do you monetize that? How do you take those things and put a value on it? Well, in most of the countries that we're seeing the most interest in new nuclear development, they're really state-owned enterprises, right? They're not necessarily private companies like a Southern Company or something like that, and nor are they municipal utilities in the instance of UAMPS, for example. So they're state-owned enterprises. They have, therefore, the political support from their ministries and from their central government that allows them and can allow them to make a go nuclear decision. But the conundrum is, okay, I've got a country that's willing to go nuclear, develop nuclear energy within their national context. How do I get the financial community to support that in a traditional way? I don't have an answer for that, other than what you're seeing in these other countries are strong motivations, very strong motivations to deploy nuclear energy that have nothing to do necessarily with the economics of the project, and a strong central government role. Question is, how do we take those political circumstances and line it up with what is essentially a global financial problem to overcome?
So Amjad, one of the
Yeah.
titles we have, and let me ask a question, and then just please jump in with the follow-up. But the one of the working titles of this is about advanced nuclear, and so we've touched a little bit about on first of a kind challenges and everything, but just putting your hat on of ex-banker, is when somebody comes to you with, hey, I've got a new technology I want to deploy and it happens to be nuclear, what's your first reaction?
Who's backstopping the risks? I mean, that's got to be the one question that every financier will ask. The equity, if somebody's looking to put in equity, their questions may be a little bit different, phrased differently. but than what a debt provider may be asking for, but it's still the same. But before I expound on that, I just want to go back to your question, a statement that you made. Has the market failed? I can tell you that in the UK, when we started this expert finance working group, that was one of the biggest sort of decisions or conclusions that was reached. Leaving the development, financing, deployment of nuclear to the market has not been working. So the government decided to intervene, and it intervened by offering to play multiple roles, covering the risks that nobody else can or is capable of covering. So I just wanted to round that discussion off. So in certain instances, and so this is in a deregulated market. So but you can take that over to a regulated market. The government still has to play multiple roles to get people comfortable once you get past FOAC, first of a kind. So
So if we're looking specifically at SMRs and advanced reactors and we want them to be effective, one of the things when we say why is nuclear different, and we already touched upon this a bit, is the role of the nuclear safety regulator. That you don't really see that to that degree of influence in other sectors. And on the one hand, you want a capable regulator, but we also know that the regulatory process can be costly and lengthy and force some changes. So, maybe Dan, starting with you, maybe talk a little bit about, how we get to, with SMRs or advanced reactors being a volume business, how do we do this in the context of regulation? How do we standardize, harmonize, whatever the right I's word is? What do we need to see to sort of really achieve the promise of these new technologies in the regulatory space without compromising safety, security, and safeguards? So, just for the audience, let's say we're not going to compromise safety, security, and safeguards. With that governor over the next part of the conversation, where do we go from there to make this a realistic opportunity?
Right. And this, in a sense, also dovetails with the previous question you asked about mega projects versus nuclear. I mean, mega projects are also not without not nuclear safety, but regulatory issues related to permitting. And I mean, try putting up, for any of the listeners in the audience, try putting up a transmission line in your home country. It's not an easy thing to do, or a chemical factory or something like that. It's not an easy thing to do. Look, one of the other things that we talked about, which when we contrasted mega projects with nuclear projects, is this nuclear safety dimension. The reason SMRs hold some promise here is that they are walk away safe. I mean, think about that. Walk away safe. They have core damage frequencies that are lower even than these safe nuclear operating fleets than we have now. So we need to take advantage of those inherent characteristics of advanced reactors, that they are super safe. The other thing to get out of this conundrum that adding nuclear safety requirements adds cost, what you're seeing a lot now are vendors that are looking at commercial off-the-shelf components. In other words, trying to build components that in light water reactors are safety related, trying to build these and license these as non-safety related. That really drives down cost. It opens up the number of vendors that are possible for you to buy your kit to put your reactor up, including, by the way, in newly emerging countries. So the combination, I think, in answer to your question, is leveraging the fact that these new technologies are literally orders of magnitude safer. We should expect the nuclear safety authorities to recognize that, and if so, it allows us to buy a lot of the plant in a cheaper, more expedited fashion that allows for overnight capital costs to be better and therefore more financeable to some degree, because what you've done is eliminated some of the deployment risks here.
Mhm. Okay,
Look,
so
I 100% agree with that. Let me build a little bit on what Dan just said. The
Sure.
idea that you have a advanced reactor design that is inherently safe means you can have safety that doesn't depend upon, as Dan suggested, bolting on some more stuff that's going to cost money to operate and to build, whether it's safety injection or emergency generators or double containments or whatever. If you can build it more cheaply, the promise is that that's going to be safe and cheap and maybe also cheaper to operate. And that's a huge upside. If you can get these things built and operating and prove that, we're going to be off and running, I think.
Okay, so I want to hit Amjad and then come back to Ed in terms of the project itself. I mean, right now we're in what I would say is still a technology development stage for SMRs. And we need to move into project delivery in order, in the next few years to address, the climate change, net zero, whatever label you want to put on it. So maybe starting with Amjad, what does a good project look like? I mean, at the end of the day, if it's a nuclear project, it's still a project. And, even if we have a great technology, does a great technology make a project? Or do you need other stuff to come together so that if people are looking to support the project, somebody's still got to pull this all together? So, it's not just a question of the reactor technology, but it's the totality of the whole thing. So, from your perspective, as we move from the technology development and demonstration project phase into project delivery, rollout, the full, business endeavor, what does that need to look like from your perspective?
There still needs to be a defensible business case, Paul. That's going to be the fundamental driver of successful delivery. So great, you got this technology to this certain point. Is there a supporting business case that will allow it to succeed? Are there willing buyers? Is there, in some instances, a developed supply chain? Because as we know, and for SMRs, you can't just build one or two. You've got to build a fleet of them, and because that's when the economics actually work. So and this goes back to an earlier point. The fact that some of these the SMRs and certainly the advanced reactors have multiple applications give rise to different revenue streams that weren't there before. So that's also a supporting economic kind of justification for getting them rolled out and getting more of them built, because as you keep replicating them and they become much more, you build them, modularize them, it's going to be easier to roll out. And so there has to be a buildup of what is the short-term, medium-term business case, and what is the long-term business case? So you've got to build that case around the technology, I believe.
So Ed, you building kind of on what Amjad just said, what do we need to do on the economic side, on the market side, if we want to see whether it's a large reactor or an SMR / advanced reactor for these projects to go forward? How do we start to create the economics to make these projects financeable, to make these the viable businesses that Amjad said? And maybe in your answer, just touch a little bit upon, as Amjad mentioned, the applications. If you're just selling electricity into the grid, that's one thing. But if you're using it under sort of a cogeneration structure to also produce hydrogen or to desalinate water or for district heating, how does that change the business model? And maybe from a planning purpose of the country that wants to do this, what do they need to be thinking about to make this happen?
Yeah, look, I appreciate Amjad's, you need a business case, and I think that's a very key point. And what does a business case mean for a nuclear project or any other kind of revenue generating electricity project? It means you have enough revenue to cover your costs and pay a debt service and pay a return. And that revenue is going to be not only enough, it's going to be certain over some longer period of time, at least certain enough to cover debt and returns over the life of the debt, which may be, we hope, longer than 20 years, so maybe 25 years, but also enough to cover your cash costs even for the rest of the life. And that's increasingly being seen as difficult. And if you're a government who also is in an electricity market, you've got to come up with some other ideas to make that revenue sufficient and certain. If you're a government who has cost control, you're going to make investments and recover the cost in your taxes or your rates. You probably are in a better position right now than countries who have a market, electricity market, they've got to work with. They've got to somehow supplement the market revenue, whatever that is and whatever that's projected to be, and do that. Your point's also a good one about revenue. I mean, we live in a world where just about every nuclear power plant in the world, almost all of them, are electricity generators, single use purpose machine to make electricity. And there's a reason for that, because electricity is a very high value commodity. It's transportable, it's all these things. These other applications, whether they're heat or they're desal or they're hydrogen, those could have a role. Some of those markets are less widespread. They're less easy to transport the product. It's less easy to switch from electricity generation to doing heat, to doing desal, to doing hydrogen. But we're looking at those things increasingly, not because they're just extra revenue, because frankly, you have to take away some electricity revenue to get them. But in a world where renewables are increasingly penetrating our industry, nuclear may have to learn how to shift from base load to some kind of load following mode. And in a load following mode, your revenue goes away if you're not operating fully. That's a problem. But if you can make hydrogen while you're not operating fully to make electricity, or you could desal water, or you could store heat like the natrium reactor, or you could have a CHP application where you're doing both all the time, that may make nuclear have another sort of tool in their toolkit to make it a business case. So I think it's a very good point.
Ed, do you mean SMRs, right? I mean, because they have the flexibility more flexibility for load following, and that's why SMRs
I mean, any nuclear power plant that you build may have these issues. And I guess I would say that any nuclear power plant can operate flexibly. And I think the economics show that. We haven't done it because we didn't need to,
Okay.
and because that was the best economic use. Technically, I mean, Bruce Power cycles their big pressurized heavy water reactor daily to follow wind. And they do it because there's an economic arrangement with the state government in Ontario to make them whole for that. Bonneville, out in the Pacific Northwest, cycles to follow hydro. They do that because they've got cost recovery agreements with the Bonneville Power Association that makes the economics work. If the economics work, these plants can cycle, and they do in some places. But some of these, the optionality though, maybe you're referring to in a small or advanced reactor, maybe it's possible to do more substantial load following, to do things like turning one module in a 12 module plant off for a while in a way that may not be easy to do.
Okay, that's kind of what it was.
Yep, the optionality is maybe greater, but the revenue still needs to be there. The business case still needs to be there.
Yeah,
Dan, I mean, what are you seeing on this front in terms of how people may be designing these new generations of reactors relative to the way they were before? And, you know, this concept of instead of saying load following, flexible generation or flexible operation, or whatever the right words are. I mean, do you see that the new generation of reactors is taking this more into account?
Yeah, I guess my view, Paul, is and I was thinking about this when Ed was making his last point. I'm unaware of any small modular reactor developer, whether light water or Generation 4, that hasn't built in operational flexibility, much more than a light water reactor. In other words, the price of admission of these technologies. So I want to take what Ed said and just say that the price of admission of deployment of these technologies is the ability to work well in the system, and particularly with renewables. It is true, there are countries I've worked with here recently that want to take SMRs and use them as baseload, and there's nothing wrong with that. But just about most of the countries that I'm familiar with want to build in this flexibility into their electrical system design so that it can work with a growing renewables base. And the second thing is, and I'm drawing on some experience at NEI where they did some public surveys. The general public tends to feel much more pro-nuclear when it is considered flexible nuclear. In other words, its ability to work well with renewables actually improves the public perception of nuclear. So whether a utility, state-owned or private, decides to deploy an SMR as baseload or to use it with their renewable portfolio, in either case, it seems to me the ability to have in the toolkit this flexible operating modality is just critical to successful deployment.
I mean, let's jump a little bit and move into something that we touched on before, which is sort of, Amjad, you had used, ESG investing and, the appetite of the ESG community. I mean, if we start from the premise that, okay, hey, you still need a good project. If we convince people that nuclear is ESG compliant or qualifying, whatever the right phrasing is, it doesn't mean that money's going to go into a project that otherwise wasn't financeable. So how important do you think, especially as we move into the SMR space, is the ESG community short term versus medium term, and what that might do, and if we want to see that, what kinds of things do we need to do in terms of taxonomy or government support to show that there's a belief that this is an ESG investment target, and maybe too, I'm going to push you on. Do you see the ESG money coming in during construction, or is it more something that would be part of a refinancing strategy so that, a host government and looking to start the program, as we've said, hey guys, you got to bear some of this risk, but if you do it for a very short moment in time in the project's life, we have this pool of money sitting out there that if we think it's ESG compliant and you structure the project right way and the economics look good, then we can roll this money into your project.
Well, you took the words out of my mouth. You need a structured solution. And, if you want the ESG community to come in during construction, it's got to be a properly structured sort of framework. And that framework needs to include, as we talked about before, the risks being borne by the government or somebody other than the ESG financiers. And we're assuming that this is an ESG compliant project. You're still going to have to address those risks. You're going to have to de-risk the project. So a structured solution may be you set up a series of milestones. And then as each milestone is achieved, the backstop falls off, and maybe you can get new investors who are a bit more enlightened to come in at that space. So that's during the riskiest part of the project. You try to de-risk it as much as possible. Once you get to end of construction and you're heading into operations, I think you're, assuming that you've got the right set of operators, you've got the regulatory framework, you've got everything there. I think that ESG community or a lot of people who are not, if you're looking for a good investment that's longer term, I think a nuclear project, an SMR, for example, that's been proven. It's got a bunch of other applications. I think it would be. I think you won't have any trouble finding money in the refinancing stage.
So, sort of sticking with the climate theme, if we want to hit our goals for 2040, 2050, we have to build a lot of nuclear, and nuclear takes time. If you look at using the UAE as an example, and if you say they kind of started in about 2007, and the first unit was coming into operation about 14 years later, that in many respects is a tremendously wonderful, successful story for a country starting a nuclear program. On the other hand, you sit there and say, well, if we're going to hit our climate change goals and deploy lots of SMRs, we got to somehow figure out how to go faster. So again, under the without compromising safety, security, and safeguards, which is kind of the absolute. Dan, how do we go faster? I mean, maybe you've seen some of the early stage projects. Is it a matter of the vendors doing more with the countries early on, the exporting governments doing more, harmonizing? Like, how do we go faster?
Yeah. So we have a couple of recent examples here. You mentioned Baraka in the Emirates, which, although the total project, and remember that's 4 units, 4 very, very large, more than gigawatt size units. Okay, so that arguably one of the largest energy centers in the world now. But that was a very, very successful project. They were able to go faster because it was an nth of a kind design. They had deployed it in Korea. That was very, very important. The ability to take staff and move from project to project to project keeps you from demobilizing and then having to remobilize. That's the first thing. And the second is, I'll look at China on AP 1000. The first unit in Sanmen absolutely was behind schedule. What people probably don't give enough credit to is the fact that units 2 and 3 and 4 came in actually somewhat ahead of schedule, their overall construction schedule. Why is that? Because, first of all, it was a design, as almost all of these new SMR designs are, at least the American versions, are modularized. And so there is true benefit to modular construction. There's no question about that. Modular construction is faster than stick building. And it's especially going to be the case with these newer technologies, which are mostly modularized. That's another success. The other thing is, and it gets to your mega project versus nuclear project, I'll take Ontario Power Generation. They've been involved in a multi-billion Canadian dollar refurbishment program, which has largely been on time and on budget. Why is that? Because the characteristics of on time, on budget mega projects, of which nuclear is the sort, you've got to have a culture of delivery. You have to have the toolkits necessary for project controls. You need to have a teaming nature. That's another answer, I think, to your question, is that I think we've realized that the delivery, the contractual framework around delivery needs to be far more collaborative than it was, say, when I was a young man building these plants. You need, and how do you do that? It means you have companies and contracts between companies that reward success and aren't as penal, so that this finger pointing that often can be the case in large mega projects doesn't occur. I don't think it's magic. I think there are a variety of factors related to delivery, not nuclear safety, not project economics, just good old-fashioned excellence in project management, in the procurement systems you put together, and in the training of the human resource capacities necessary to put these plants together. It isn't magic.
Yeah, I'll add 2 things for Amjad and Ed on what Dan just said. I mean, Ed, in terms of where Dan started, he was talking about fleet, multiple units to achieve economies of scale, in certain efficiencies, if you will. But, when we talk about SMRs, maybe there's economies of multiples too. and certain efficiencies that may be created. So, when you start to think about deployment in the economic sense of things, how do you see things in terms of one unit versus fleet, and how countries might be thinking about deploying reactors and achieving efficiencies?
Yeah, look, I'll say, just like Dan said, that every one of these companies, these advanced reactor, small modular reactor companies, have done flexibility as a feature. All of them have done the learning curve as a feature. And the idea that the only way this design is going to work is if you build 20 of them or 6 of them or 100 of them, whatever the number is, that allows you to do all those learning curve things. It allows you to take some of those learning curve issues, as Dan mentioned, not at the site, not moving learning from site to site to site, but having it in one factory in one place, maybe for some of these companies. So that now you've got a skilled workforce, you've got templates, you've got all kinds of quality control, and you've done multiple building of all the bits you need for this small modular or advanced reactor that gets shipped to site. And that factory can be very efficient, replicating the things, and highly efficient. And the learning curve, just like for automobiles or airplanes or anything else, the learning curve can be very steep. And so the nth of a kind, whatever that number is, 6 or 20 or 100, can be very low compared to the first one. And I think everyone wants to do that. But you mentioned earlier, though, that the problem is, how do you get that market? How do you get 100 or 6 or 10 of them built? That's not so easy. And so there seems to be some agency issues here. How does a builder and seller of this small modular advanced reactor somehow factor in the benefits of learning for future units into the current unit? Someone's got to take some investment risk there to get to that nth unit, and that's always difficult. In the large reactor space, we had companies who built, like Oyster Creek, for example, some of the first large nuclear power plants in the US. They took huge losses on those because they knew they would get future orders and they could get down that learning curve and make money in the future. Some of them did. Maybe it didn't work so well in others, but there's got to be a way for those economics to work out. And the one way I see that happening is for a government to make a big order, and to make a big order that sort of locks in not only the numbers and not only the factory and the location and the reactor technology, but lock in the capturing of the learning. And that's going to be the big task for these guys, not selling them one at a time, each in a different country, but selling a package of them, a whole set, if you will, to a country that'll be built in a fairly short time.
Okay, so we're approaching the end of our time, and I want to ask a question of everybody to finish. But before I do, I'm going to trade on my friendship with Amjad and say I'm going to ask you a question that is impossible to be answered briefly, but I'm going to ask you to answer it briefly. And it's something that Dan touched on in his answer that I really want to highlight and not slip. It wouldn't be right to do so, which is, in the contracting space and collaboration and those types of things. And we see that risk and price move together. And just, again, I apologize for being unfair with this question, but from a risk perspective, how do we need to be thinking about risk in the project sense, and what do project planning authorities need to be doing in order to pull these projects together from a risk allocation and management perspective, and pricing and contracting and all what do you do?
I mean, I think you need a capable team walking you through all this entire process. I think it's hard. I was just just the last week, I was in a country where you had very eager, and driven, young, inexperienced people trying to deliver a nuclear program, and sitting across them was somebody that was very, very experienced, and it was throwing wolves to the lions, and it was very hard. So I would say that one of the one of the major things is that, you have to either you build up the capability internally in terms of management skills, in terms of experience, or you need to engage someone to assist you in this process.
And I mean, where does the project risk register fit into this process?
It's sorry, I mean, that's one of the first things that you would look at. And you have the main project risks, and then within that you've got multiple risks, variations of certain risks, and all that has to be addressed early on in the process. And then you can start the allocation process. You can say, okay, who's best to bear this? An example, if you're an equipment supplier, what risks is an equipment supplier willing to take? Is he willing to fund? If he is not, unwilling or incapable, what is the give back to the home country for sharing that risk, or having the host country take that risk? So risk register, risk assessment, risk allocation, risk mitigation, absolutely critical at the front end. And that requires people who have done this before. It's a tedious process, but it has to be done.
Mhm. All right, thank you. And again, apologies for that completely unfair question.
That's right.
But I just want to hit just very quick, because we're really just wrapping up now, and just run through with everybody. We'll just kind of go Ed, Dan, and then Amjad. If we were to say, just pick one thing, and it could be from the perspective of the exporter, the host country, the IAEA, anyway, what's one thing that we have to do better? Or from the financial community, there's more than one thing, of course, but if you were to pick one thing as we move, towards our, clean energy goals and moving into SMRs, what's the one thing that we have to do better or take particular note of in order to achieve the success we hope to see in between, say, 2030 and 2050? What's that one thing? And we'll start with Ed.
Look, I'll go back to something I said earlier, and that is that these nuclear power plants are 100-year packages of lots of different attributes, some of which have a lot of value, but doesn't get reflected in electricity markets. And so you need somebody to be the decision maker, the policy maker, the buyer, the developer even of these plants, that can recognize the value of these attributes and make decisions around them. And usually that means the government must have a role.
Mm-hmm. Okay, Dan, to you, what's that one thing?
Yeah, I would say it's and it gets to the question you asked Amjad unfairly, which, what's that magic bullet? And I'm afraid there isn't one. But if I look at, for example, what my own advisory practice is focusing on now, it's this notion of a collaborative approach to deploying these projects. I think everyone understands that the old way of doing things didn't work as well as it could or should have. And so the risk in projects drives up the price. I mean, there's a positive correlation. The higher the risk, the higher the price is going to be, the more it's going to cost the end user. And de-risking these projects is very important. But de-risking isn't me giving Ed my risks, okay? De-risking is collaboratively coming up with ideas and project structures which allow for a less fault-based approach, okay, where the risks are driven down. And it includes, to Ed's point, it includes governments, utilities, and the major contractors, not all the contractors, but certainly the reactor technologist, the constructor, and any other engineering and procurement entity. That's a minimum critical mass we need to put these projects together in a way that make them less risky. And that's an innovation. That's a commercial innovation.
Thanks, Dan. And Judd, what's that one thing?
And they stole my thunder. It's structuring a project so that it's de-risked with somebody behind that who can take the risks, and typically in nth of a kind, it needs to be the government. So it's de-risking, risk allocation, risk mitigation, the government playing a major role. That's a recurrent theme that we've seen here today.
But this, and I'm just going to ask one back to you to wrap it up. Does the government have to take that risk for all time, or are we asking the government to take that risk for a certain point in time that is difficult, after which point others can step in?
Absolutely, absolutely. That's what we talked about, sort of a structured solution. You achieve certain milestones, the backstop falls away. And this is all we're looking at for nth of a kind. And as for first of a kind, but as we get to, unit number 7 and unit number 8, there's a track record to look back on. So people should get very comfortable with that. And if they're an enlightened investor, ESG, enlightened investor, enlightened financier, they should be able to take that risk. All else being, all nuclear risks being taken care of, everything else structured properly. If you're now asking someone to take project kind of risk, as opposed to technology risk or construction risk, and once you get past that stage, I think the private sector should be able to better assess and better take that risk.
That's a great thought to end on. So with that, I'd first like to thank everyone who's listening to this. We thank you for your attention. We hope it's been very useful to you. I'd like to thank all of our panelists, Ed, Amjad, Dan. We all happen to work together under the aegis of Nuclear Economics Consulting Group. So, it's great to do this with a bunch of friends and colleagues. So guys, thank you so much for stepping up and doing this. And then last but not least, to thank the Department of Energy for asking us to do this. This is, as I mentioned at the beginning, this is, sponsored by the United States government as part of the IAEA 65th General Conference. And, it's unfortunate that we can't all be in person due to world events, but, hopefully with this virtual session, this can be a useful tool. And again, with much gratitude to the U.S. government and, of course, the International Atomic Energy Agency, who plays a key role in everything that's done throughout the world. So with that, I thank you all very much and have a good day.
Thank you.
Thank you. Goodbye.
Thanks a lot.